Hi everyone, welcome to this video. In this video, we're going to discuss some concepts about integers. So now, when we talk about integers, we're going to use the definition of set, where it's a set of whole numbers, zero, and negative whole numbers. When we talk about whole numbers, it consists of the counting numbers, then zero. However, we go specifically with zero so that it has its identity and negative whole number. So when we write that in a set, in a listing method, we could say that it is continuous from the left. So I could have now negative 3, negative 2, negative 1, comma, this is the 0, and then 1, 2, 3, and then continuous going to the right, which is, which is like that. Okay, now, let's now identify now if it is an integer or not. So let's have some examples. So I have here these numbers. And this one. Okay, now, this is an integers. So we can say 7 is an integer because it is a whole number, right? 1/2, not integer, because we can say it is a fraction. Now, 2.5, that is not integer because it is a decimal. Now, 4/2, meaning it is 4 divided by 2, and the answer is 2. Therefore, it is a integer. Now, negative 8, we know as is negative 8, so therefore, it is a integer. Now, let's have now another concept that would help us further understand integers. Now, that concept is known as the number line. The number line is a model that we use to visualize what are numbers. However, we will go specifically to integers because integer, in a word, it's integral. And when we say integral, it is whole. So, going to that, so let's look at that. There are two orientation of number line. The first one is the horizontal orientation, and then the other one is the vertical orientation. So the horizontal looks like this one, and then the vertical looks like this one. Okay, now let's create now a number line so that we can now understand what is its how it will be visualizing the integers. Now, working with that, I'm using now a horizontal line, and then there should be an arrowhead. That means it's going to the right, it means it's positive. And then here, going to the left, it's negative. Now, I put now a demarcation for the integral. It should be equal in its position. Assuming that what I'm illustrating now are equal positioning or equal distances between the integral. So we can work that out. So let me just put everything here. So this is a number line. Now, I'll put now, we have this one. So this is now, you can put anywhere. You can say 0 could be the center, but I could say 0 is the starting point. So this is now 0. And going to the right of 0 are positive. So it will be increasing. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, going to the left of 0 are negative numbers. So we'll start with negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and then negative 7. Okay. Now, let's have some ideas about this one. When it's going to the right, we known as the positive integers. And then going to the left of 0, it's now negative integers. So that's how you illustrate now a integer. Now, using now a number line, we can plot an integer. When we say plot, we know the positioning of plot 7 in the number line. So when we plot now an integer in the number line, we started with 0 and then go with the distances because they are equal. So this is the plotting of 7 where it's located there. So that's now how you plot now 7, and that's how you visualize it. Now we can plot another number, plot -5 in the number line. Forgot to put the line there. So when you put that, you can put it here. So from 0, it means that 5 distance from 0 to the left. So 1, 2, 3, 4, 5. So it would be here as the position of -5. So I'll put a demarcation. The name is 7, and this is now -5. So that's how you visualize now a number line. Now let's have another concept that we could understand: integers. So we're done with the definition of integers. We're model now the integers in number line. Let's go with another concept that we could look at. So let me open another notes that could be utilized here. So I have here some statements that could represent integers. So let's have that. So let me have it. Okay. Now, let's write the integer that represent the situation now. Hearing this one, looking at this one, we could have now read and then have the value of the statement. Now, let's go with the first one. A gain of 45 liters. So, we could write it as positive 45, or we could say it's 45, or in some other teachers or some other education institution, they write it plus 45. But in my case, I would like to write you that is 45. What makes it positive? Because of the word gain. So it is now positive 45 or 45. Now, let's go with number 2. Number 2 is 15 degrees below 0. So when we say below, it goes down. So therefore, it could be represented an integer by -15. Another, an elevation of 1050. So the word elevation give us an idea that it's positive. So we could write it as 1050. Another, in the finances, we could say a profit of 50 pesos. A profit means it's an additional, so therefore it would be positive 50. Another concept, a loss of 5 pounds. So when you say loss, it means that it was deducted from your weight or from your mass. So it would be -5. Now another thing, now when it comes to navigation or like in water, we could have 350 feet below sea level. So the keyword there is below. So it would look like this. -350 is the integer that could represent it. Now, another thing in concept of finance, 2,000 pesos deposit in a bank. When we say deposit, you save money. So therefore, you'll have now a value of 2,000 in your account. While in the other way, other instances, 3,000 pesos withdraw. So you spend in a bank. So you have now a -3,000 as a symbol in your bank account. So I think that's how you represent now integer in a more practical notion. Okay, let's go back to our notes before. So let's have here. So we have now the 3 ideas. The first one, we define now the integers. We have different cases. So we have now number line. Now let's go now with comparing integers. Let me have my pen once again. Now when we compare integers, these are 2 numbers. Whether you try which one is bigger and which one is smaller. So in comparing, there are symbol such as the first one is equal. The other one is greater than. And then the last one is less than. Now, which means this have different relationship on two values that you are comparing. So for example, it's a clear example if you have two positive numbers such as 2 is equal to 2 because 2 have the same value on the left side and the right side. Another, we have now negative 5 is equal to negative 5, where negative 5 are equal on the positioning. It's just on the same. If you would visualize that in the number line, they have the same position. Now, let's go on the other sense, which is greater than. When you say greater than, which means opening, which means they have a greater value. So for example, the first case, if you're comparing two positive integers such as 4 and then 2, technically 4 is on the right side. So they technically, when you visualize that in the number line, we could say that 4 is greater than 2. When comparing two negative number, which one is on the right side in the number line when you compare? Like for example, if you have negative 1 is greater than negative 3. And then when you compare now a positive and a negative number, a positive will always be greater than a negative number. Like 5 is greater than negative 2. When we reverse now the relationship, we can say that in the lesson is that 2 is less than 4, negative 3 is less than negative 1, negative 2 is less than 5. So that's how it works. So let's go to a website that I'm using. So on how to compare now an integer. I'm using now Math is Fun. Let me have that. Okay. So let's go with comparing. Okay. Comparing numbers. So these are the symbol that I told you. Same, less, more. So let's have now an example using now a number line. Okay, comparing numbers. Okay, as you can see here, let me just make it a little bit bigger. So as you can see, when you want to look at that, which one on the right of the number line would be greater than on the left side of the number line? In this case, if you have now negative 6, we put now negative 6. So negative 6, so they are just the same. So we can now put now equal. Okay, how about this one? Negative 7 compared to 8. As you can see, 8 is in this position of the number line, right? And then negative 7 is here. So, technically, which one is greater? Which one on the right side of the number line would be greater? So, technically, you'll put now 7 is less than, negative 7 is less than 8. Okay, another one. Here, let's look at now 8. Once again, 8 is here. And the negative 6 is here. So, which was us on the right side of the number line? So, which one on the right side of the number line, that would be greater? So, now, in that case, when you compare, 8 is greater than negative 6. Okay. In this case, once again, 8 is here. And the negative 2 is here. So, 8 is on the right side of the number line. So, therefore, it should be bigger. In this case, we have now 2. And then we have 6. So, 6 is on the right side. So, we could say that 6 is greater. Okay? I think we're done with that. So, thanks to that website, you can use that website, mathisfun.com. I think we're done with comparing integers. Now, let's have now the last part of this video, which is ordering integers. Now, when we say ordering integers, there are two order that we could use. The first one is least to greatest. And then the other one is greatest to least. When we say least to greatest, you started with the smaller value going to bigger value, while the reverse is the greatest to least. Now, it's a very good thing if we have now a number line. So let me put now again a number line so that we could see now the ordering when we order now your integers. So, fortunately enough, we have now integers given like 6, negative 5, 3, negative 2, 0, 1, 4. So let me have that. Okay, let me now put now my numbers. So I have here negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14, 15. Now, I'm going to plot all the numbers one at a time. So I need to plot now 6. So 6 is located here. So I could put now 6 so that I could put that there. Next, negative 5. So negative 5 is located here. Then I have 3 here. And then let's go with negative 2. Then I have 0. And then 1, and then I have 4. So we can now have now ordering. So when we order now, because you plot it or you visualize it, least to greatest. If you plot that in a number line, or if you visualize it, even though in your imagination, you could say that the least value is negative 5, followed by negative 2, 0, 1, 3, 4, then 6. Now, on the other hand, we can now put now greatest to least. We started from the right going to the left. So, it's just a reverse. So, we have now 6, 4, 3, 1, 0, negative 2, and then negative 5. So, that's how you order now your integers. And it would be a great help if you have your number line with you. Once again, thank you for watching this video. Have a great day, everyone.